to begin with, let me show you kind of how to set this up. I'm only going to do one of these problems, and then I'll have you work a little bit of that in your recitation. So this is called, this part right here, f of x plus h minus f of x over h. We call that the difference quotient. And I want to show you how you work this out, okay? Generally, this is something that you're always going to be tested over. It's a good algebra problem. It's good to practice this a little bit. So here, this is the way I teach you how to set this up. So what I want you to do is just draw kind of, you're going to take up a lot of space on your paper. You want to put like 2 brackets and really space it out real big on your paper, and that whole thing's going to be all over h like that, okay? So what the difference quotient tells you to do is f of x plus h minus f of x. F of x is going to go there. I gave that to you. I'm always going to give you the function, so you want to put that thing in the second bracket like that. So that's going to give you 3x squared minus 4x minus 3 like that. Sometimes students who have never done this before have a hard time setting it up. Now what you're going to do in the first bracket is you do the same thing, except everywhere you see an x, you're going to replace it with parentheses x plus h. Okay, so it's a good idea to start there and then copy that over there, but write it like this. Okay, you just do the same thing, except you say 3 times x plus h squared. Then you still say minus 4, but instead of x, you say x plus h, and then minus 3 like that. Okay, that's the difference between that. If you had, and I made a little mistake on that, that square should be outside parentheses like that. Okay, does that make sense? That's what I give you. That's the same, except x turns into that. All right. Now, what you do with this is once you get it set up, there's a bunch of algebra that goes on in this problem. And what will generally happen on this at the end of the problem, that h will generally cancel out if you're going to do this correctly. So I'm going to do a couple of things over at the side of the paper. All I'm going to do is just go through and let's work that part of the problem out right there. So I want to focus on starting there, then the rest of it's a lot of basic algebra. Okay, do you guys, can you do that in your head? Can you tell me what it is? X squared plus 2xh plus h squared. Okay, if you don't know that, you can write it out twice and FOIL it. So again, when you do that shortcut, you just square the first term, you square the last term, you multiply those two things together, x and h, and then you double it. Okay, it's good to know how to do that fast because you'll do that all the time on these problems. Okay, so now what I'm going to have you do is we'll just write this as 3 times, and replace that now with x squared plus 2xh plus h squared, and then everything else you can go ahead and start distributing. So that's going to be minus 4x and then minus 4h. Got to be real careful with your signs when you do these problems. Okay, and then we've seen this a lot. So how does that minus affect everything there? That's going to change the signs, right? You're going to have minus, plus, plus. So be real careful with your signs when you're doing this problem. So that's minus 3x squared plus 4x plus 3, and then this whole thing is going to be over h. I don't really need that bracket anymore. The purpose of that was just kind of to show you kind of how to get this thing set up. Okay? All right, now what's going to happen on this is a whole bunch of things are going to start canceling out. Now let's go ahead and do this distributive property. And you want to write, several steps on this, so you're real carefully doing this. That would be 3x squared plus 6xh and plus 3h squared. Now I'm just going to rewrite the rest of it out, and then I'll show you kind of how this works out. Okay, then we'll start looking for all the things that cancel out on the problem. So let me pause there just for a second and let you get that taken down. Okay, anybody have a question what I've done so far? Okay, now our purpose in college algebra, we don't really care that much about what the difference quotient is, but we want to get you comfortable with that. It's a good algebra problem. You learn a lot more about that in a calculus class. That has a real important meaning in there. All right, let's find all the things that cancel, because there's a bunch of them. So you'll notice that the 3x squareds are going to cancel, the 4x's are going to cancel, and the 3's are going to cancel. And on this particular problem, what's left, I'm highlighting what's left, it all has an h in it, doesn't it? And that's pretty typical when you're working with a quadratic function. That's what's going to happen. So we're going to go ahead and let's write what we have left. It looks like we have 6xh plus 3h to the second minus 4h all over h like that. And then what's going to happen on these problems at the very end, you're only going to do a certain number of functions on that. That h is going to cross out. So what can you do to the numerator? Factor. How do you factor that numerator? Does it have a common factor? Yeah, there's an h in every position. Now that's all you care about, okay, is just getting that h out of there. So notice what you have is you have an h in every position. So to finish up the problem, what you want to do is you want to take h out, have a parentheses, you'd be left with 6x plus 3h minus 4 all over h like that, okay? And then what will happen is the h is going to cross out, so the final simplified answer is 6x plus 3h minus 4. Okay, how many people took calculus in high school, just out of curiosity? So you learned about the difference quotient and doing the limit as h goes to 0, okay? So it's the same idea, except we don't talk about the limit in college algebra. So you stop there, but you would be used to letting h go to 0 and getting the derivative. So we do that. Okay, so does anybody have a question about how I worked that out? Okay, I definitely want you to get comfortable with that. What I assigned in the homework is stuff with quadratic functions, linear functions, not stuff with square roots and fractions. You do a little bit more of that in a calculus class, okay? All right, so I want you to know how to do a difference quotient. You'll see that on your first exam. That's a pretty standard problem that we want people to do. You see it on the final exam too in this class. All right, so next thing we're going to transition to is talking about domain of a function, which we've talked about. If you're looking at a domain, what are you looking for, x or y? X, okay, you're looking at all the values that are permissible of x. Now we're going to kind of categorize these. One of the things we're going to make sure we know how to do is how to, if I give you a function, be able to figure out the domain without necessarily having to graph it. And I'm going to categorize this in really about three main things here. So to begin with here, a linear function, we already know the linear function is y equals mx plus b, okay? So what we would have with that is we have y equals mx plus b, and then a quadratic function, that's the one that you use quadratic formula on, that's ax squared plus bx plus c like that, okay? So those are basic things. So what will happen is the domain of a linear function is just going to be all real numbers. And if you want to write that in notation, interval notation, you would write that like that. Now the way I look at this, and if you write this in, I wanted you to do this in set builder also. So if you do this in set builder, we've done that before. Usually you say set of x, and then you say such that. There's two ways you could do this. You could just say x is a real number. You can just spell that out like that if you want to. Okay? Or you can do it like this. Okay? A lot of times you will see me write it this way, and it's just as well to learn how to do this. You say x, this little e says that it's a member of the real number system. A real number is usually written like with an R with a double bar on it. So you can just write it out like that, or you can use that symbolism. But you want to know how to do both of those things. You want to be flexible, that you can do interval notation, and you can do that. Okay, now the reason for that's real simple is because if you have a line, x can be anything. Okay, you can take x and multiply it by any number and add a number to it. There's no zero denominator, no problem under a radical, anything like that. So if you have a linear or a quadratic function, the domain's everything. Okay, all right? The second thing I want to look at is a rational function. And first of all, what a rational function is, I'll give you a couple of examples. Rational functions look like this. First of all, they are fractions, and the numerator and denominator are what we call polynomials. Okay, so I'm going to look at just an example, something like, let's say you have x minus 4 there, and let's say in the denominator you have something like x squared minus 25. That's an example of a rational function. Now, since it's a fraction, what's the deal with the denominator? What do you not want that to be? 0. You can't divide by 0. So when you have a rational function, your focus becomes, I need to look at the denominator, and that's all you got to look at on a rational function is the denominator, and you figure out what causes that to be 0. So you want to just figure out what makes the denominator 0, so you set the denominator equal to 0. Okay? And what you'd have on this is you would just solve this equation, and that would give you the places where you'd have a 0 denominator. What's the answer to that equation in your head? 5 and negative 5. You can either solve that by factoring, or you can move the 25 the other side. Use your square root property like we've learned. Now, if you do that, don't forget to do the plus or minus, so you'd have x is equal to plus or minus 5. Now, if you write the domain on this, now remember, when you're writing the domain, you're telling me what x can be. So you got two choices you could do on this. You could write the domain like, in interval notation, you could say negative infinity to negative 5, and then put a parenthesis there because we know that x can't be negative 5. Then we can go negative 5 to 5, and then union, then we can go 5 to infinity. And the reason you're doing it this way is when you put parentheses around those numbers, what does that tell you? It tells you the function can't be those numbers, right? Okay, so that's how you could write that in interval notation. You got to break that up into parts like that. Now, if you do it in set builder, this is good enough if you do this in set builder like this. You can just say set of x. You can say x is a real number. Then comma, you just say x is not equal to plus or minus 5. So you really got to say it's a real number, but it can't be equal to those two numbers. So that's how you typically do things on a rational function. Find what makes the denominator 0, and then take that out of the domain. It'll be everything else. It'll be everything except whatever those values are. And sometimes a rational function, the denominator will never be 0. It all just depends on how that function's written. Okay? Everybody with me there okay? Okay? So we want to kind of look at certain cases of these. The third case that I want to look at on here mainly is this, okay, where I have square root. Okay, so first of all, here's what you want to know about a square root. A square root of a positive number is okay, right? Square root of 0 is 0, so that's okay. What's not okay is a square root of a negative. Okay, so that's the whole key thing to think about. If you're looking at a domain of a square root function, you got to figure out what under the radical would make that positive or 0. So what you do if the radical is in the what you want to set what's under the radical greater than or equal to 0. Okay, so let me give you a couple of examples on this first of all, just kind of show you what you do. I'll keep it kind of simple at this stage. So let's just say we have the square root of, say, x minus 1. Okay, now you can reason this out in your head if you think about this. Okay, what would be let me ask it this way, what would be the smallest value of x that would work on this problem, just in your head? 1, good, because 1 minus 1 is 0, and the square root of 0 is 0, right? Okay, if you get bigger than 1, it's okay. Like if x is 2, 2 minus 1 is 1, square root of 1 is 1. What's not okay is a number like that's smaller than 1. Like if you plug a 0 in there, you would have a negative under the radical, right? Now you're not always going to be able to do that in your head, but what you can do is you can take this thing, whatever's in the radical, it'll always be the same. You just take that and you set it greater than or equal to 0, then you solve that inequality, okay? That one you add 1 to both sides, so you would have x is greater than or equal to 1. So if you were writing your domain, this is how you would write that on that example. You would either say, in interval notation, you would say bracket 1 to infinity, okay? If you were doing that in set builder, you would say set of x such that, and then you just say x is greater than or equal to 1, like that, okay? So always when you're dealing with a radical, you want to make sure that that is going to give 0 or a positive number. Sometimes it's a real simple inequality to solve most of the time. Sometimes it's a little bit more involved, okay? All right, I do want to show you one more thing. You don't necessarily have to write this down, but you will sometimes encounter this. This is slightly different, so I want to show you this. So if the square root was in the denominator, it's slightly different, okay? So let me ask you on this and see if you kind of catch on to this. You know that that number under the radical has to be greater than or equal to 0. But it's not okay for it to be equal to 0. How come? Because it's in the denominator, exactly. So in this case, if the function was this, you would solve this inequality. You couldn't say equal to 0 because you can't have that equaling 0 in a denominator of a fraction. So if you solve that, you would end, if you solve that, you would end up basically having this then for your domain. You would just end up having x is greater than 2 would be what your domain is on that. You see the difference? Okay? So you got to make sure that you understand where that radical is in the problem, and that'll give you kind of the basic cases: radicals, rational functions, lines, and polynomials and stuff like that. That's what we're going to focus on, okay? It's just certain kinds of functions. Okay, so let's go through some specifics on this. A lot of these you'll be able to do in your head. Okay, what kind of function is number 19? It's a line. So what does that tell you about the domain? It's everything. Why? Because a line goes forever to the left, forever to the right with no gap in it. There's no place where that function's undefined. So set builder, you would just say set of x. Let's learn to do it this way. X, funky E, funky R. Okay, kind of like that. So that's just kind of the mathematical symbolism you see a lot of times in textbooks as you write it like that. Okay, in interval notation, what would it be? Negative infinity to infinity. Okay, that's automatic because you know it's a line. Okay, you've got to recognize linear functions always work out that way. Okay, if you begin to look at the next problem here, what happens on this one is, okay, this is a rational function. So what do you look at? What's your focus? The denominator, okay? So is there anything that x cannot be in this problem? Just in your head. Great, yeah, x cannot be equal to 3, okay? If you can do something in your head, that's fine. So really what you're doing is you're just solving the equation x minus 3 equals 0. So if you're going to say this in set builder, you want to say set of x. Then you would want to say x is a real number, and then just say x is not equal to 3. So it's everything except 3. All right, that's the way rational functions always work. How would you do that in interval notation? Negative infinity to 3, union 3 to infinity. Now you'd have to have parentheses around the 3, good, so you'd have like negative infinity to 3, and then union 3 to infinity like that. So you have to break it up into intervals like that if you're doing that in interval notation, okay? That's a problem you just do in your head, okay? Sometimes rational functions are pretty easy to do in your head. Everybody okay with how this is working out? Okay? We're going to try to look at, different situations on these problems. The next one's a little harder to do in your head, but what this one is basically doing is you have a rational function again. So what is your focus? Your focus is basically the denominator and what makes that denominator 0. So what you would do is you would just take the denominator and set that equal to 0 and solve that equation. How do you solve that equation? What's the fastest way? Factor. That's a quadratic equation, so factor it. If it factors, if it doesn't, you've got to go to the quadratic formula. So this one should factor as x minus 8. Nope. That would be, it'd be x plus 8 and then x minus 2. Because that way the inner and outer come together to make sense. So in your head, what are the places that would cause the 0 denominator? Negative 8 and 2. Because you don't have to do this part because you can do it in your head. You're solving that equation and you're solving that equation. So what you would say is the two things that x cannot be are negative 8 and 2 like that. Okay? And that's just because of the factoring. All right? So if you said this in set builder, the way I want you to do this is always just say x is a real number, but tell me what it can't be. Okay, and a rational function, a lot of times it can't be a number or a couple of numbers or something. So then we just say x is not equal to negative 8 and 2 like that. Okay? If you do that in set builder, what would you have to do? How many intervals would you have to have? You have to have 3. You'd have to go negative infinity to negative 8, and then negative 8 to 2, and then 2 to infinity, because you want to go left to right like that. So you would write it as negative infinity to negative 8, have a parenthesis, and then negative 8 to 2, and then 2 to infinity like that. Okay, and again, the key thing on that is the parentheses around the negative 8 and 2 are just saying it can't be that, but it can be everything else. Okay, everybody with me there? Okay, so that's the way that you would go about doing rational functions, and that's mainly what you're going to see is set the denominator to 0, figure out if there's any problems. Okay, now I want to show you this also. You don't need to write this down, but I wanted to just show you something on this, and I don't think I put one on here quite like this, but you can write it down if you want to, because every now and then you'll come across something like this. You might have f of x equals 1 over x squared plus 4. Okay, that's a rational function. okay? Now, I want you to think about this. Okay, if you take any number and square it, what's going to happen? You're going to get some positive number. You might get 0. So is it ever possible for that denominator to be 0, just in your head? No, because if you pick a number and square it, that's positive, right? And then positive plus 4 is just another positive number. So that one, the domain would actually be all real numbers. If you don't see that in your head, here's what you would do. You would just set the denominator equal to 0. You would try to solve that equation. You could do that by the square root property. And notice what happens is you would get x equals plus or minus, and you would have a square root of a negative number, okay? And that doesn't count, okay? We're not even talking about imaginary numbers yet in this class, but that doesn't count. So for that reason, the domain would be all real numbers, okay? So there is no place that causes a 0 denominator on that. That's what you come across every now and then. Does that make sense? Okay, all right. Okay, let's do one kind of last idea on here, just do a couple more problems, and I think that'll pretty much wrap up what we need to do on here. The last two sections we do in here, particularly 3.2 and part of 3.3, are pretty basic. They're kind of pre-calculus stuff. So with this one, now we have a radical. So what's your focus? What we need to figure out what under the radical is greater than or equal to 0, right? We know that we can only do a square root of 0 or a positive number. So the way you do this problem is you would just write that down and set it greater than or equal to 0 and solve that inequality. And then that would give it to you, okay? There are several ways to do this. I'm going to do this one this way. I'm going to just kind of to review something. So I'm going to subtract 8 from both sides. I would have negative x is greater than negative 8. All right, now I'm still not done. What do I need to do to both sides to have that x by itself? I can either multiply by a negative or I can divide by a negative. So if you were to divide by negative 1 on both sides, that would give x, that would give 8, but what do you have to do? You got to switch the sign. Good. Okay, anytime you divide or multiply an inequality by negative number, you got to change the sign, because if you don't, then it would be you're backwards. Okay, so that changes everything. So what that would be then is that's really your domain right there. So if you write that in set builder notation, you would say set of x, and then you just got to say x is less than or equal to 8. That's all you got to say, because that's built in that it's every real number 8 or below. Interval notation, you just do this, bracket 8 and infinity like that, okay? Now, a lot of times students, I can tell, like when you're doing tests and stuff, a lot of times don't catch mistakes. When you do a problem like this, it's actually very nice to just see if you're right. So if you took this function and you plugged in 8, look what would happen. You'd have square root of 8 minus 8. Is that okay? Heck yeah, that's square root of 0. That's good. What if you took a number bigger than 8? Like what if you did 9? Then you'd have square root of, whoa, hold on. You know what? Teacher just caught his mistake on that interval notation. The interval notation is not that. How should I write the interval notation if it's less than or equal to 8? Negative infinity. So I just got my mistake by checking my answer. I didn't mean that. That wasn't a part of the lesson plan. So that's how that goes. That's how your thing should go, is like that. Okay? Well, let's take like a number less than 8. Let's take like 7. Well, if you plug that in, you would have 8 minus 7. Is that okay? Yeah, you're doing a square root of a positive number. Okay? So if you take your domain and just kind of plug in a few numbers, you can tell if you're on the right track, okay? And that's a good way to make sense out of all this stuff anyway. So as long as you're less than or equal to 8, you're going to have a square root of a positive number. So that's the idea, okay? All right, the next one's real important, okay? This is one if you don't pay attention to, you might mess up on. Okay, so first of all, if you were to go through and do this problem, that factors, doesn't it? Okay, you would end up having x plus 2 times x minus 2. And then if you factored that denominator, that's the difference of 2 squares. So you would say x plus 2, x minus 2 like that. Yeah, it's true that that cancels out and gives you 1, but that's really a different function. It really, really is a different function. Even if you graphed this, if you graphed that original on your calculator, it would look like this. It would just be a straight line going through 1, but it would have 2 little bubbles in it. Okay, so you can do this in your head. What are the 2 numbers that would make that original problem 0? 2 and negative 2. So you got to take that out of the domain. Don't cancel stuff. Don't even look at that. In fact, when you're dealing with a rational function, you just look at that. That's all you got to look at is the denominator only, So you would do, again, x squared minus 4 is 0. You can do that in your head. Square root both sides, you'd have x equals plus or minus 2. Okay, so you can't be plus or minus 2, so that means the domain would be written like this. You would say set of x is a real number, and then you would have to say x cannot be equal to plus or minus 2. And you can do that abbreviation. You don't have to write both of those out. I know what you're talking about. And then interval notation, you'd have to do 3 intervals. You would go negative infinity to where? Negative 2. Then where? Negative 2 to 2. And then where? 2 to infinity. Okay, so it's got to go like that. You got to break it up into 3 pieces. And again, those parentheses are eliminating those 2 numbers. Okay, does that look good to everybody? Okay, so remember, it's a rational function. Look at the denominator. Okay, because we're kind of looking at functions in a limited way in this class. We're just looking at certain types of things like that. Don't cancel. Okay, actually, one thing that you learn a little bit later in this class is since they cancel, you get little holes. So you'd actually just have a couple of holes in the graph with a horizontal line. That's the way that works out. Okay. All right, so that's pretty much what we're going to talk about with domain. So that's pretty well the end of that. I'm going to close this off here.